We're going to look at equations with variables on both sides, and we're going to address the question, how do you solve equations with variables on both sides in a second. First, we want to do some reminding about equations and what that represents. We know that when we look at an equation, we're basically looking at a balance. What we want to do is, if we're going to add something to one side, we want to make sure in order to keep it balanced, we add it to the other side as well. If we are to remove something from one side, we want to make sure in order to keep the balance, we remove it from the other. And the same is true with the inverse operations of multiplying and dividing. What you do to one side, you do to the other. These are the properties of equality. Now, what I want to do before we get into actually looking at equations is give a little bit of a visual representation of what this should look like. Here I've drawn a balance, and on one side of the balance, as you can see, we have two x's and a positive 2, and on the other side we have an x and a positive 5. So I'm going to get a little bigger scenario here to play with. I'm going to keep this one to remind us of where we started with. So what we want to do, like we just said a moment ago, is to keep the balance. So let's remove an x from both sides. Okay, when we do that, when we take away an x from both sides, we're still maintaining the balance. We're taking away the exact same thing. Now, when we look here at a 2 and a 5, we're not going to be able to grab them both. So what we need to do is maybe change that 5 up a little bit. And let's change that 5 because we know a 3 and a 2 combined will give us a 5. So let's replace that a little bit. So we still have 5 on that side. That hasn't changed. See the 5, it's still 5. But now, since we have a 2 on each side, we are able to move the 2 away. Okay? And what that does for us is it shows us that the X box represents a value of 3. Now, if we take that information and we plug it back into here and put it in there and see if this is true, is this really what it's going to take to keep it balanced? Well, we have 3 plus 3 is 6, plus 2 more. This side will give us 8. Here, 3 plus 5 also gives us 8. So it is maintaining the balance. And we've talked about this, about doing operations to both sides of the equation and checking our answer. And the reason we check our answer is to make sure that we are maintaining that balance. Let's do another one here. Let's take a look at this. Here I have an x and a positive 4 on one side of the balance and 2 x's and a negative 5 on the other. We make it a little bigger and an extra one to play with so that we have the spare one back there. So again, we probably want to remove an x from both sides to keep it balanced. And then we want to remove the negative 5, but since there's a 4 over there, we're going to need two numbers that are going to give us, add together to give us negative 5, one of them being negative 5. So what that will take is a positive 9 and a negative 5. We know together that that will give us positive 4. So let's replace that. So we still have 9 and negative 5 because is it 9 minus 5, 4. So that's still the same. That hasn't changed. But now that we have the same block on both sides, we can pull that negative 5 off of both sides, still maintaining the balance. We can see we've only pulled out things that were exactly the same. And when we do that, we've maintained the balance in finding out that the x represents a 9. So let's put a 9 into the blocks to see if that is true. 9 plus 4 is 13. 9 plus 9 is 18, minus 5 is 13. So we see that it's balanced. So something to think about, if we were to take these last two equations we were looking at and actually translating them to what an equation would be. In the first one, we'd have two x's and a positive 2, and that would equal an x and a positive 5. Same representation. What we represented, we ended up removing an x from both sides. We removed an x from both sides. And then we ended up with what we were saying, x plus 2 equals 5. And we replaced it. Remember, we took 2 away. Isn't that what we did? We took 2 away from that. So when we took 2 away, we ended up with x equals 3. Those were the steps that we had done. Okay? Let's take a look at that other one that we had done. And I'm going to kind of put it on this one here. And excuse me for that a second. I've got everything disappearing on me. So what we want to do is, using the same idea, let's see if we can recreate this. So If we look at our original equation, we have x plus 4 equals 2x minus 5. So we said we took an x away from both sides. Subtract an x, subtract an x. Okay, that left us with 4 equals x minus 5. And we took away a negative 5. Taking away a negative 5 is basically adding a 5 to both sides, isn't it? So we added 5 to both sides. And we found out that the x was 9. And then what did we do? We took that 9 and we plugged it in to find out if it was true, and we found out that it was. So you see, just what we were showing you with these little blocks really is what we've been representing with our equations. So just to kind of give you a little bit of add-on. So how do we solve equations with variables on both sides? Well, what we're going to do is combine all our steps of what we've been using so far. So first of all, we're going to distribute if it's necessary and combine like terms. Now, normally we would just look on each side individually, but this is where we're adding, and this is why I have the arrow here. We're going to try and combine our terms or collect our like terms of our x's. We want to collect our x's to one side. I'm going to suggest to you that you go to the side that has more positive variables. The reason for this is so you have positive coefficients only. It'll make it easier. That way you either multiply or divide by a positive number as opposed to a negative number. And then you want to solve it like we have before, like a two-step equation. You deal with the non-variable term first, which is called the constant. We would add and subtract that. Then you deal with the coefficient of the variable term. Then we would multiply or divide. Remember, we always check our solution to make sure that we are correct. So let's take a look at this problem. We have w plus 6 equals 4w minus 4 plus 2w. So here we have two terms on the left side, but we have three terms on the right. That means that a couple of those terms have to go together. So let's keep the left side as it stands right now. And since there are three terms over here, we see that 4w and 2w do combine and go together. So 4w plus 2w is 6w. So now that we have terms on both sides that are variables, we want to say which ones are we going to keep, which one are we going to get rid of. Now, we could get rid of 6 minus 6w from both sides, but that's going to give us a negative coefficient. So we want to maintain, always work towards the side that has more positive. So since 6 is larger than 1, let's get rid of that 1w. So let's subtract a w from both sides. That will leave us a 6 on the left. 6w take away w is 5w. Then we're back to a two-step equation. Dealing with the constant, we're going to add 4 to both sides. Simplify. Dealing with the coefficient, 5 times w, so that means we're going to divide by 5. And we find out that w equals 2. Now, what we want to do is just like we did a moment ago. We want to check our solution, and just like I took that number and put it inside the blocks, we're going to do the same thing. I'm going to take that w equals 2, and every time I see a w, I'm going to replace it with a 2 to see if I'm correct. So 2 plus 6 will be on the left. On the right, 4 times 2 minus 4 plus 2 times 2. See what's going on. 2 plus 6 is 8. Working on the right side, 4 times 2 is 8, minus 4 plus 2 times 2 is 4. Remember, in order of operations, we always work left to right. So we'll do 8 minus 4 first. That will give us 4. And then 4 plus 4 will give us 8. So it does check out. So our answer of 2 is a good answer. It maintains the balance. Let's try another one. Here we have 3x plus 15 minus 9 is equal to 2 times x plus 2. Let's separate our sides and take a look at what's going on. Here we have three terms on the left side, so we need to combine like terms. This 15 minus 9 needs to go together. So we're going to get 3x plus 15 minus 9 is 6. On the right side, we need to do some distributing. Parentheses tell us that we need to multiply towards the number that's outside the parentheses, or variable, or negative sign, meaning -1. So here we would say 2 times x, which is 2x, and 2 times 2, which is 4. So now we're back to a standard equation, and on the left side we have 3x, on the right side we have 2x. We need to keep the most positive variables in order to help us have a positive coefficient. So we'll keep the 3x and we'll get rid of the 2x. So let's subtract 2x from both sides. 3x minus 2x is just x. Canceling these out will leave us just with 4. Using inverse operations on the constant, instead of adding 6, we're going to subtract 6. And that leaves us x equals 4 take away 6, which is negative 2. We're going to check our solution. And once again, what we're going to do is take this value of x equals negative 2, and we're going to plug it into the places where the x is. So we rewrite 3 times negative 2 plus 15 minus 9 equals 2 times negative 2 plus 2. It's working on the left side here. 3 times negative 2 is negative 6. Negative 6 plus 15 is 9. And 9 minus 9 is 0. Working on the right, starting from the parentheses, negative 2 plus 2 is 0. 2 times 0 is 0. We bring it down, it checks out. So x does indeed equal to negative 2. Now, in the real world, equations with variables on both sides help us to compare costs in different situations. So I've got a situation here for us to look at. Peppy Pets charges a flat fee of $15 plus $3 an hour to kennel a dog during the day. Happy Hounds charges a flat fee of $21 plus $1 per hour to do the same. For how many hours is the total fee charged by the companies going to be the same? So one idea for us is to test information for 1 hour. So let's take a look at Peppy Pets. Okay, and we find the information, we underline a flat fee of $15 per hour plus $3 an hour. So for 1 hour, it's going to take the flat fee of $15. We're going to add together $3 for that 1 hour, giving us a total of $18. Now we'll do the same thing for Happy Hounds, and it says it charges a flat fee of $21 plus $1 per hour. So flat fee of 21, and for 1 hour it's an additional $1. So Happy Hounds is going to charge us $22. Now if we were doing a comparison of, hey, what's 1 hour worth or 2 hours, we can keep testing this way. But the easiest way to do this is to write an equation. And we can do that with the information we have. We want to make sure that the fees charged by the companies are going to be the same. So in other words, we need an equation that has an equal sign on it. And one will be on one side, we'll have Peppy Pets on one side, and we'll have Happy Hounds on the other. Now, we do know there has to be a variable involved because we don't know how many hours. So x is going to represent the number of hours. So when we look at what we've written for 1 hour here with $15 as a flat fee, $3 an hour, we're going to put our x there because that's what's going to change. So we will have 15 plus 3x on one side. For Happy Hounds, the $1 is what's going to change. So 21 plus, and we'll just list it as x. So now we're going to go ahead and solve this equation. 15 plus 3x equals 21 plus x to find our common hours. Okay, so let us combine our x values. Let's subtract an x from both sides. And again, I'm going to draw a line down the middle so people can see the balance in action. So we have 15. 3x minus x is 2x. Those x's cross out, and I have 21. Then I'm going to try and isolate this x by getting rid of the constant. So I'm going to do the opposite. So I'm going to subtract 15 from both sides. Remember, showing what we do to both sides, right? They have to be exactly the same, just like we did with those balances. We took exactly the same thing off of each side. All right, and that's going to leave us with 2x equals 6. Then we're going to divide both sides by 2. And we find out that x equals 3. So how many hours is the total fee charged by the company is going to be the same? The answer is going to be 3 hours. So hopefully that helps you a little bit more in understanding how to use variables on both sides and to solve a real world question as well.